just like that. Welcome everybody. Thanks for being here on time. Let's see. Did you guys unmute yourself or did I? Okay, so
I'll send my email.
Oh, there you are.
Perfect.
What are we working on?
Okay, you see this thing right here, the high voltage charging system? It's not really high voltage. Huh. What should you do before you begin testing the charging system? Disconnect the battery cables?
Yes, sir.
No.
No. Oh, a charging system. Oh, okay.
Yeah, disconnect all the wires from the alternator.
I think it's something else.
Yeah.
The bottom one, consult the information.
That's correct. Okay.
Yes, call Dave.
Work. No, that number's been no longer out of service.
Right, Dave?
All right, number 2. Point out the following parts, but that's really basic. Okay, so that's the battery. That's the alternator, and charging system indicator lamp's got to be around here somewhere. I can't see it because I got.
Should be the red light on the top, no?
You would think so, but I don't know. That's like the oil light to me.
Yeah, that's
It's right here.
Can't see it.
This big thing right there.
Yeah.
Can you see my
There
screen?
it is. It's real small.
Yeah, if you guys are using a phone, that's going to be a problem. All right, let's go over here. Charging current check. Look at the information on the alternator cover. 14 indicates the regulated voltage. Number indicates the charging current. Boy, I didn't know that. When the rotor is spinning at 1800 RPM. Third number is the charging current at 6000 RPM. When the rotor is spinning at 1800 RPM, what is the minimum charging current? 17?
I figured it out.
Well, the second number, right? 17?
Yeah.
Check.
Yeah.
Amazing.
Hey.
All right. So it seems to me you guys should be able to whip through this pretty quick, but I would not spend a lot of time on the basics because I think you already know them. Now, this is cool, and you can see why this is a $9,000 a year program.
Ooh.
Yeah. So start the engine and set it to 2000 RPM. How do you start the engine? This thing?
Try turning the key area right there.
Probably the plus.
Headlight, yeah.
Are those headlights? I don't know. I don't know how you started.
Okay, so the
Press
engine,
the plus on the charger.
that's the key right there.
Oh,
So
yeah.
it started. You can see the RPM is like 600.
Yeah, it started.
Okay, so now I'm going to turn this little rascal. I'm checking the voltage, so I'm going to go over here to, they want me to go to 200, but I would go to 20 myself. All right, that's DC or AC, like we talked about last time.
I think you got to raise the RPM on the
Right.
slider on the top.
Oh, okay.
Oh, there we go.
That's cool.
Oh.
Man,
Hey.
that's cool. Okay, check.
Hey.
Okay. Thank you, Chuck.
I've been doing it.
Yeah, looks like connect the voltmeter between the B plus connection. That's going to be this one right there. B plus connection on what? The battery? Right there? Huh. And the alternator. Where's the B plus connection? That thing right there? Huh.
Yeah, right there.
Chuck, why is it? Oh, this.
See that
there.
exposed view
Right
right there?
Right there.
Okay, I got you. Where do they want the negative? Right there?
That's crazy.
And then I'm going to put this to 20. Isn't that crazy, Daryl?
That's crazy.
That is cool as hell. Yeah, so guys, this is what I was saying earlier. I don't know how much longer the subscription on this program goes, but it might be 2 weeks. I mean, it might be a month, but whatever it is, you need to get on this and pound your way through it like crazy.
Okay.
Because this is big medicine.
Yeah, it's interesting.
Ah!
Oh.
Uh-oh. Uh-oh.
Uh-oh.
It's not properly connected. What?
Something went on or something.
What in the world? How do they want this thing connected?
Is it all the way on 2000?
It says B. It says measure voltage between positive B connection and the alternator housing.
Right, there you go. Okay, so it goes there. Or what do they
Which
want?
means you gotta move the black lead to the positive terminal on the battery.
No, they want it on the alternator housing. But I don't know where their little magic, is that it? Yeah, there you
The
go.
bolt.
Bill 14.
There you go.
Oh,
Oh, okay, you know what that is? That's the nut for the pivot.
Yeah.
Okay, I get you. 489826, who are you? Anybody know who 489826 is?
No.
I have no idea.
Sounds like a prison number.
Well, yeah, huh? Why don't I just do a roll call? It's not Jimbo, Tomas, Nanan, Charles, Michelle, James Knott, or Big Rudy. So who are you, 489826? Oh, it's Daryl. Oh, I'm sorry.
Oh, there. 48982. Hold on, let me look at my.
There you go. Yeah, okay, gotcha.
I'm new to this, so I don't know.
Yeah, me too. Yeah. So I'm cruising on this. I think this is a cool program.
Yeah, it is.
Okay, what can you say about the regular? See, the problem is, you know, I ordered the freaking screen to get me like 2 monitors, but they gave me the wrong wire, so now I can't do it.
Bummer.
What can you say about the regulated voltage of the alternator if it's not under load and the rotational speed is increased?
Voltage is too high.
Measure the voltage. Okay, first of all, they want me to measure the voltage. So I'm going to go back here with the black lead. I'm going to go over here with the red lead. And then I'm going to kick my voltage to like 20. What can you say about the regular? Okay. Find out the range within which the regulated voltage is delivered by the alternator should be. Measure the B plus connection.
For being the.
Measure voltage is okay. What can you say about the regulated voltage of the alternator if it's not under load and the rotational speed?
Within range.
It's within range.
Yeah, it's within range. Okay, there you go. Good. So that's how you do it, folks. And it seems to me you should be able to whip your way through this pretty quick.
Okay.
You have now finished the lesson. Okay, go back. Now, the good thing is, Chuck, I need to point out, the good thing is, Rudy knows this too. The good thing is you're not going to blow up my meter doing this wrong, right? So I appreciate that. So see, your navigation is up here. So right now you're on charging system. So come back here to electrical and you could do lighting systems, I suppose. Headlight aimer, that's interesting. Headlight cleaning, how about? Oh, it doesn't do you any circuits? Or does it?
What about light theory?
Does it? Where's light theory? I don't see it. All right.
Or network theory?
Light basics, maybe.
How about battery?
Battery.
Boy, that's a lot of quizzes. Okay.
Yeah.
Measuring. Okay, start module. Boy, I can see someone who's going to be out of a job pretty quick. What is the voltage of one battery?
12 volts.
12 point. 12 point. Oh, 12 volts, yeah.
Let's see, 12 volts.
12.6. 13.
13.62.
Well, that's what it's supposed to be.
Oh.
But it's,
Oh, they're saying connected in parallel or series.
yeah,
Sorry, voltage, okay.
says no. What is the voltage of one battery?
Yeah. 13. 13.5, 14.5.
I don't believe you.
12.6.
Look at the imprint on the lead acid battery. It says 12 volts, right?
Yeah.
But then it says some weird thing under here, like it's in German or something. Oh, okay. Because I put 12V. That's the problem.
Yeah.
Yeah, I'm thinking the
All
V.
No.
All right,
The
here we
V is
go.
on the side.
Okay.
What is the capacity of one battery?
70.
Tell me.
70.
70.
That is correct. And you can just hit enter. Okay.
Okay.
Batteries can be connected to one another okay, so if I come here,
In series and parallel combinations.
Oh, wow.
that is crazy, man.
Which is what I want to do to my golf cart.
Brother.
Burn up all your motors.
No, I
Okay.
want to, because my golf cart's a 36-volt system.
Oh, yeah, yeah.
It's got 6 6-volt batteries in it. I want to put 6 12-volt
Wow.
batteries. Keep the. So what I want is I want to put them in series and parallel combination.
Yeah. You could use 3 12-volt batteries, right? Okay. All right, so there we go. Connect the batteries in parallel. So I'll go from here to there. Check. What? Well, it used to be right. How do they want it?
You gotta check to get the negative.
Is it positive to negative or positive to positive?
When it's parallel, it's positive to positive.
Oh, okay.
There we go.
Mm-hmm.
Okay. So anyway, that is the Electude thing. There's a lot to do. And Tomas discovered that I assigned you like 400,000 hours of instruction. But that was just so you can do whatever you want.
Right.
You know? What's
Yeah,
that?
I'm muscling it out.
There you go. Where's Anna Maria?
I don't know. She called me like an hour ago and I talked to her.
For shame. Man. Okay, so good. I'm pleased about that. I'm really pleased with this. I mean, it's gonna take a while to get through, right? How do you get
Yeah,
back?
sure.
How do you get back to where you began? Go
There's
back.
an invisible arrow right there.
Huh. Okay.
Right there. Invisible?
Well, it's a lightly shaded arrow. You can see one in each direction when you're on the
Right.
lesson.
Yeah. Okay. Yeah.
Okay, I'll find it.
All right, boy, this has got everything, which is good because the MLR's actually got a whole lot of content. So this is actually cool, and hopefully they'll fund it for next year. But man, I got to find myself a better job, steady job, you know. So, anyways, this is what I found right here is when I go to Chaffee Adult School. This is all students that I. Daryl, you're not Bull Brown 83?
No, they got that absolutely wrong.
That's why.
I text you my email correctly.
Yeah, I got that.
Yeah, that's all the way crazy.
What happened to Tony?
What happened to Tony? I even sent him a
Yeah.
reminder. You know who's busting it out is look at this guy, Juventino Rivera.
Mhm.
He is making it happen. So you guys need to join him. So the cool
How many hours do I have?
Well, that's just in that topic. But how many hours you have is too much stuff in my way. You have 6 hours and 32 minutes and 4 seconds.
All right.
Good man. But jeez, Juventino's got what, 29 hours on this?
Yeah. It's pretty
What,
good.
hold on. What is that though? I'm lost.
That's how long they've been in the program.
Oh, okay.
Tomas Perez is busting it out
Yeah.
too. Yeah?
Yeah.
Good. Well, that's
Wait,
not
how much hours do I have?
2 days and 9 hours, so that's like 56 hours, something like that.
Oh man.
Good, keep you out of trouble, right? Hey, Jim Knott, is that your is Jim Knott still here?
Yeah.
Is that your email address?
Yes, sir.
Well, what the hell? All right, so what I'm gonna do is try to move this stuff around a little,
This doesn't work over here.
and I'm gonna come up to new share,
Oh, okay. Here we go.
and I'm gonna go to advanced, and we'll go there. Yeah?
Yeah.
Okay, so let me show you the old-fashioned way. What I wanted to point out was we got what?
Do you have a timing light at the house I can borrow?
I got one at the shop, I think.
Yeah, but not one at the house, huh?
No, the timing on the Forerunner is perfect.
No. It's for a Yukon.
What year?
90 something.
Yeah, it's gonna be an early one. Yeah. Top pick.
Jerry needs me to go check his timing.
When?
Tomorrow?
No, I can't get down there that quick. I got Perkins I got to do tonight and tomorrow. Easy to buy one. All right, 4-3. That's tonight. This is next. Yeah, this is the last night. Now, my plan was to do last night of instruction. I don't know. You know, we got to make up for a lot of lost time. So you can do any. Have you heard anything about signing up for next semester?
No, not yet.
Yeah, me neither.
They don't have my right email address. So I ain't gonna...
Well, go by the office and correct them, you know, because there's 5 or 6 students just from this class don't have the right email address. So yeah, it's rough. So I already sent the principal, the administration, an email about that, about how we need to be much more careful. But I mean, nobody was expecting this, right?
No, this was unexpected.
Except
It wasn't like it was planned.
yeah,
it could have been.
Yeah.
It makes you wonder.
Michelle, did you see they were laying off one medical group was laying off 14,000 nurses and doctors in California?
Yeah, that's insane.
Doesn't sound like a medical emergency to me.
I'm starting to have my doubts about this whole thing.
Yeah.
Yeah.
Well, that's gonna be a sweet dollar bill, I'll tell you. All right, so let's go like this. We should be able to move through this pretty quick because I'm assuming you're going to be studying when you are not with me. I got a light bulb right there. What's that dotted line?
Ground side.
Oh, here we go. PIR. Okay.
Yep. Dotted line is ground side. See, the positive is here, the negative's there. The ground is considered to be the negative terminal. So I guess you could go like that if you wanted. Now, see the difference between the ground and the battery? Battery goes long, short, long, short. The ground goes long, shorter, 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 dot. Okay, so we got 12 volts here. Is that DC or AC?
DC.
That's DC. You know it's DC because it's a battery, right?
Right, it's always DC.
And I got 4 ohms here of resistance. Now that resistance is going to turn into heat. This is a light bulb. That heat is going to turn into a glow, and that's going to give us light. So what do? The first thing we do is write down whatever we're given the example. E is volts, so I'm going to say 12 volts because it says so right there. Resistance is 4 ohms, so I'm going to put 4 ohms right there. And Daryl, if you're not crystal clear on this, just watch last week's lesson on YouTube. It's all in there. Yeah? In fact,
I watched some of last week's.
Yeah.
Okay.
Oh, hooray. Man, I wish this thing made a ding or something when people showed up. It doesn't. All right, so let's see. Join. Hey, SMT 550, who are you?
Mm-hmm.
Oh, SMT 550, who is that? Hey, it's Anna Maria. Okay, good.
There you are.
Yep.
Okay, I got it.
There you go. All right, so everybody knows everybody?
Yeah.
Jimbo, when are you going to get your camera fixed?
When am I going to get my what?
Jimbo Rodriguez, when are you going to get your camera fixed so we can see your beautiful face?
I'm lost on the road clip.
Hey.
I'm kind of lost on the top right and right in the middle.
Okay, you mean right here?
Yeah. What's that?
This is a circuit, right? So every circuit has 4 elements, I guess we'd say it. Hey, did you know that I'm about to finish up 100 pages in this class just in 3 weeks?
Cool.
Yeah.
I thought that was pretty cool. Yeah. Okay. Every circuit has 4 elements. What are they? 1.
Watts, volts, amps, and ohms, right?
Ohms. Yeah.
Well, no, that's true, but I'm talking about the parts of the circuit.
Oh, okay. It has the beginning part. The relay is in there, right?
You have
Is it power?
your source, your wires, your load.
Oh, okay. That's what you're asking.
Yeah.
Power source.
Now, the power source can be AC, DC, can be batteries, can be rotating magnets, can be Hoover dam, whatever.
Right.
The conductors.
Could be a solar panel,
Yeah, for sure.
wind turbine.
The conductors is what connects all the parts together.
Mm-hmm.
It's going to have some form of control to turn the circuit on or off, or make it go faster or slower. And it's also going to have the load, which is the whole reason the circuit's there. Like, for instance, if we had a lighting circuit, the load is the light, yeah?
I couldn't hear that. I'm sorry.
Someone should probably hit the mute button somewhere. Sorry, what'd you say, Michelle?
I couldn't hear that last sentence you just said. I'm sorry.
The load is the reason the circuit exists.
Okay.
So if we have a lighting circuit, the load is the light. If we have a heating circuit, the load is the heater.
Okay. Got it.
Okay, so here's what we do, Daryl, make it really, really easy. All you have to do is multiply up or divide down. So 4 times what equals 12?
4.
3.
3.
3.
3.
Oops.
Three.
Oh,
Sorry, I'm lost, dude.
sorry.
That's why we review. Yeah.
Yeah.
Okay, 3 times 12 is what?
36.
36.
36.
Oh, my math skills are sucking.
Yeah, it's
I'm just all the way out of it, to be honest.
without practice.
Because I can't see the R is a 4 and a 3, because it looked like a 4 and a 5 too.
No, that's a 4.
No,
And
that's
an ohm.
that's an ohm. That's for ohms.
That's this thing.
Oh, okay. See, that's where I was lost. That's where I was lost.
There you go.
Okay.
Welcome back, dude. We've been wondering about you. Glad you made it. I don't know what's going on with Andrew Heeks. Probably still mad about the muffins. I hope. Man, back in the day. So I'm 2 pounds away from my high school weight.
Brad, you look great.
Crazy, man.
You look great.
You got this?
Well, stand up and let us see you.
You can tell just in your upper body. You can tell you lost a lot of weight.
Yeah, I got.
Wow.
Yeah.
Very
You
good.
look good.
Clap for the doctor, right?
Hey, you feel a lot better too, huh?
Oh yeah.
Yeah.
But yeah, I got to slowly cycle through all the mistakes I made in my past life of sin, but we'll get there. Now we need the elective surgeries to come back, right?
Yeah.
All right. So you got
trying
this?
to get my damn hips done.
Right. Okay, let's just do a little review to make sure we're still cracking it. Now, you'll notice that these circuits don't have a control because it complicates it. For what we're trying to accomplish, complicates it. So I got this thing here, it says M on it. And then I dot my dot. P-E-I-R. P is for power, measured in watts.
Right.
E is for voltage, measured in volts.
Volts.
I is for electrical flow,
Amps.
measured in amps.
Amps.
And R is resistance. So that's going to be 12 volts there. And what do we do? Let's say 20 amps.
20 amps.
20 amps. Yep.
Okay.
There you go.
12 volts.
And
Okay.
Okay.
Cheers to you guys. Thanks for being here.
Okay. 240 watts.
You'll never believe it. Oh, there's a chat right there.
Oh, wait.
Okay, this one's hard.
Nah. Well, you got a calculator?
Yeah, I need a
My
calculator.
math
That's the
skills
thing.
are way out of practice. Let's just say that.
All right. Well, we write down what we know, right? Because we
Yeah.
know that E is 12 volts, and we know that I is 20 amps.
Right.
So do yourself a favor, cheer yourself up. What's 20 times 12?
240
That's correct. 240 what?
watts.
Watts.
That's very correct. Good. Now, 12 divided by 20 is what? 0.8?
1 point something. Right?
No, it's going to be less than 1.
Yeah, it's gonna be less than 1.
It's 0.8, isn't it? Or 0.4?
0.8 sounds good to me.
I got 0.6.
0.6.
I messed up. Yeah, you're right.
0.6. 6 ohms. That's very close to a dead short, right? Dead short would be 0 ohms. Now you say, okay, so why are we learning this stuff? Well, I'll tell you why. Over here, I have, I'm going to do this like this. Yeah, here's my battery. That's a plus, a minus. Then I'm going to come over here like this to a bulb like this. And then I'm going to hit ground light right there. And then I'm going to come over here and hit ground right there. Make a better drawing for you. There we go. So these are basically connected, right? Because ground is common to everything. Now, here's the thing. If I want to know how much resistance there is in the circuit, that's hard to test. Unless I come over here with my ammeter. Put on amps, DC. I'll just make a beautiful drawing for you. There you go. That right there is called an inductive ammeter. Now, what does an ammeter measure?
Amps.
That is correct. Good. Be right back.
Oh no, he left us. So back to what we were talking about earlier, where they were showing the batteries.
Aha.
See that?
Yep.
All right. Boy, I wish I had my double monitors, man. Anyways, men don't say I wish. Did you catch that? Now that's, Anna Maria, that sounds like something I would say. Men don't say I wish. Men say this is what I want. This is how I'm going to get it, right?
Yeah.
Yes.
If you're dealing with an adult and they keep saying I wish, out.
Yeah.
Okay. This thing right here is an inductive ammeter. Now, you can get ammeters pretty cheap, but that's because they're not going to tell you anything useful. When you get an ammeter, you have to get one that says
Amps.
it's got to say amps DC. See how this says amps AC?
Mm-hmm.
Every ammeter is going to measure amps AC, but you got to go and get the one that says amps DC. Because after all, look, we're dealing with a DC circuit, right?
Yeah.
How do you know that's a DC circuit, my friends?
It's
It's
all
off a
batteries.
battery.
It's got a battery, right? Okay, so this is an inductive ammeter, and I can turn it to amps DC. This right here is a Fluke 362. It's what I use. Now you can see that it says 0.3. That's because inductive ammeters are picking up on this big old LED light that I just installed. Can you tell I changed lights? Yeah, I got this big old LED light.
Yeah, you're a whole lot brighter now.
Yeah. So you got to hit 0 every time you use an ammeter. You got to hit 0 so it runs this to 0. Now, whatever wire I clamp this over, anywhere in this circuit, it's going to give me a current reading. Now, this one's cool because it'll also measure volts. It's got that capacity. I don't usually use it for that, but you can do it. Now, amps DC, I don't know how many amps it can. The good thing about these is you can put all kinds of amps on them and it doesn't really bother them because it's inductive. Anyway, that's an inductive ammeter. It's a wonderful, wonderful tool. Chuck, you got one?
No, I'm going to get one, but I got a question for you on that inductive meter. Let's say I had to troubleshoot a light window switch on a car.
Yep.
I just run that across the wire to see if I got voltage going to the switch?
Yep. No. Well, yeah. Well, I mean, it's used to test current, right?
Okay.
So if you were to, okay, so you're talking about a window motor, right?
Right.
Window motor draws a large amount of current, but sometimes the window motor will get stuck and it'll just draw a bunch of current and not move. And we want to find out, well, is it getting current? Well, so you clamp one of these on one of the wires that goes to the motor, and if you see it kick to 15 amps and the thing doesn't move, the motor's bad.
Okay.
Yeah? Yeah, you got to have one of these, dude.
Well, when I see tools like this, I'm going to upgrade my game, so that's on the list.
Yeah. Because what happened was, you know, I had a parasitic drain problem in the Suburban where it would kill the battery in like 3 or 4 days. This is the only way you're going to find that. You know, so you put this over positive or negative term, it doesn't matter. Put it over positive or negative wire, and what I was seeing was it was pulling over 1/2 amp at all times. Well, that's a battery killer. So just based on my experience, you know, me and Rudy go way back on this. You know, aftermarket alarm systems, after a certain age, they just start messing with you. You got to get them the hell out of your car. So this one actually had 3 different fuses in it. So I took out one fuse and the power drain went down. But then I looked under it because I still had the problem. I looked under the dash and I found 2 more fuses. You just take 2 more fuses out. It's like the English patient. You just take the 2 more fuses out, and then I checked my parasitic drain and it was down to 0. And that made no sense to me because it's still powering the radio and stuff like that, but it went down to 0. So, you know, if you got 0 parasitic drain, that means the battery's not going to drain.
And that's off the positive terminal, off the battery? You just hooked it up to it?
Positive or negative, it doesn't matter because in a series circuit like this, the current is the same everywhere. So no matter where you put this, it's going to tell you the amount of current. It's going to, which, look, if I know the amount of current, I can calculate the circuit resistance. This is the power of the Ohm's law thing, because when I look at this circuit, I'm like, oh, okay, this is what I should expect. So when I use this and I find a reading that doesn't make any sense, I know there's something wrong. Get it? I don't have to test the resistance because one of the things you're going to find out is this motor right here is going to change resistances when it gets hot. And it's also going to change resistance when it's running. So it's like really the only real accurate way of knowing what the circuit resistance is one of these. Buy it used off eBay.
Well, it's a fluke.
Of course, fluke if it works.
What's the model?
362.
Huh?
362. Yeah, I've been really, really happy with it. Now it says right here, Cat 3. Yeah, it says it's rated for 200 amps, which means, I don't know, can it do an alternator, Rudy?
Should be able to.
Yeah.
It can even do a small Honda starter.
Yeah, exactly. Uh-huh. Well, that's correct.
And it was great using it when I had the system in the car.
Yeah, exactly, sure. Because what you can do is any wire you hook it to, it's going to tell you the current flow in that circuit. Now, let me ask you a question. If I hook it this way, or if I hook it...
Oh, that's even better. Sorry.
If I hook it this way or if I hook it this way, is it going to blow up the meter if I hook it up wrong?
Yeah.
No.
Yeah.
What's it going to do?
Just read.
It's going to give me a negative number.
Oh.
So...
There is polarity to it. Okay.
Okay. So, yeah, well, yeah, because it's DC, right? But I don't care about the polarity really, because I mean, if I'm checking the wire that comes from the alternator, I know which way the current's going, right? So I can check to see if the alternator's charging. You know, the Suburban was idling and I was getting like 11 amps. I was like, okay, so the charging system works. Then I shut it down. Now, just as an aside, just because it's relevant, when I shut off the car, when I shut off the Suburban, it went down to about 2 amps for 30 seconds. Why, Rudy?
That's all the computers and everything shutting down.
Yeah, all the computers have to go to sleep, plus the dome light is kept on for 30 seconds, right?
Mm-hmm.
So as soon as that went down, it went to 0, and it's like, okay, now problem's fixed, right? See, because Chuck, nothing's better than confirming a repair, right? Where's Arnold?
He said he's gonna try to get online. He's in Bakersfield.
Wow,
Again.
that's kind of cool. Well, I hope he's enjoying himself. Okay, so my question to you is, because this is the same issue. Right here, I've got this thing on volts now, volts DC. And I check the battery like this. Is the red lead supposed to go to the positive terminal?
Yes.
Yep. And the black lead goes to the negative terminal.
Yep.
Okay. So let's say it says, I don't know, 13 volts. Let's say I was careless, though, and I went like this. Is that going to blow up the meter?
Nope.
No, we're going to get a negative number.
Just give you a negative number. That's why I focus on teaching students, especially beginning students. I focus on teaching students volts, because, you know, the volts thing, you're not going to blow anything up. It's got super high resistance inside it. You're not going to blow anything up. You can pretty much run this I'm not suggesting you be careless, but you can pretty much run this anywhere. And, you know, it really tells you a bunch of stuff. Like yesterday, I mean, last time we were talking about charging systems, right?
Mhm.
Right?
Yeah.
Mm-hmm.
Yeah.
Yes.
Okay. So charging systems means we need to, are you guys done with this?
Yeah.
Yes.
Well, let me just write one more thing. Measuring current tells us the resistance. Okay, you got that?
Yep.
Okay. All right. I've got 2 mountains and a pipe that goes between the 2 mountains. If this mountain is at 14,000 feet and this mountain is at 12,000 feet, will water flow down the pipe?
Yeah.
Yes.
Sure.
Yes.
Okay. Here's another mountain. Here's another mountain. This is at 12,000 feet. That's at 12,000 feet. I got a pipe between them. Will there be flow?
No.
No.
No, because there's no difference. Flow is created by the difference. All right, so here I have a mountain at 14,000 feet. And here I have a mountain at 4,000 feet. Will there be flow?
A whole lot of flow.
Oh, yeah.
A lot of flow, right?
Mhm.
And this is the whole idea behind voltage regulation in the charging system, right? Because we've got 14 volts here, which is typical charging voltage. We've got 12 volts here, which is shorthand for the battery. Battery should be 12.6, but let's just call it a 12 volt. And we can see that in order to get electrons to flow into the battery, the charging voltage has to be higher. Yeah?
Yeah.
Yeah. Yeah.
Okay, so what we're going to do is we're going to put the battery right here. Just like that. It's a battery. It's got a minus and a plus. And then we got the alternator over here. Alternator. And it's grounded. Hey, how does the alternator ground?
Through the engine block.
Yeah, through the case, because it's mounted to the engine and the engine is grounded, yeah? Okay, so this comes up here to a ground, just like this. And then what I'm going to do is I'm going to come over here with the output of the alternator and put it right there. And that's how the charging system works. And hopefully, which way are the electrons flowing? Away from the battery or to the battery?
To the battery.
That is correct. Yep. So what I'm going to do is I'm going to come over here with my beautiful voltmeter. I just put it like that, put it on volts DC. And I'm going to bring my red lead over here. Now, I do the leads like this. See the little arrow thing? That's how you can tell they're leads of a voltmeter. And I'm going to come over here and I'm going to go like that. Is that the correct hookup for checking charging system voltage?
Yes.
Yes. Is that also the, okay, but if you're checking charging system voltage, the engine has to be doing what?
Running.
That is correct. So, turns out that this is the correct way to check two very important things. With the engine off, that's the battery voltage. Or you could say state of charge, but that's not technically as accurate.
Charging voltage.
Nope, because the engine's off.
Well, I mean when it's on.
Yeah. But we'll do one thing at a time.
Okay.
Okay, so the engine's off. I've got my voltmeters hooked up like this. Oh, sorry. I got my voltmeter hooked up like this, and I'm currently testing how many volts the battery is. How many volts should the battery be?
12.6
to 13.2.
12.6 to 13.2 DC, right?
Correct.
That's correct. Good. Okay. Now, if the battery voltage is 12.4, does that mean the battery's bad?
No, just weak, low.
No, just weak, right? Just needs a charge. Yeah?
No.
Okay. In a little while, I'm going to teach you something about when you lose a cell in your battery. But for now, yeah, it just means it needs to be charged. Turns out that if the battery is actually 12.0 volts, that means it's halfway discharged. You got a long way to go. Because let me ask you a question. When I crank that starter, what's going to happen to the voltage of the battery?
It's going to plummet.
Yeah, it's going to go way down. And that's another one of the tests that we're going to learn how to do tonight, I think. Okay, so with the engine off, this is how you check the battery voltage. Now, I was silly and I wasn't careful, so what I did was I put those wires on the wrong terminals. Is that going to blow up my meter?
Yeah.
No.
No? Oh, yeah, that's right.
It's going to give it a negative number.
Yeah, it's just going to give me a negative. One time I was at the podiatrist and he was looking at x-ray of my foot and he put it in the viewer upside down and I was like, I mean backwards. I was like, no, that's wrong, right? That probably pissed him off. You know how podiatrists are. Anyway, so engine on. Okay, so what are we testing if I turn the engine on with this setup?
Charging voltage.
Charging.
Watts.
Yep, charging voltage.
Voltage. Oh, shit.
Now, we talked last week about a whole bunch of complications to this. If you don't remember, be sure to watch that video. Man, I'm proud of these videos. You know, it's like the only teaching. Well, never mind. So, charging voltage. How much charging voltage?
13.6 to 15.2.
Hey, Rudy, have you had any problems with the charging system on the 4Runner?
The alternator's a little weak when you turn on all the lights.
Yeah, I thought it was a little weak, period, but it looks like it's the original equipment.
Yeah, that's what I told my mechanic. He's like, hey, has the alternator ever been changed on this thing?
I don't think so. Well, I mean, you just don't want to get stuck somewhere, especially if you're off-road. All right, so same setup, but what's the difference between these two tests? One, the engine's
power
off.
coming through?
Yeah,
One's off, one's off.
The other one's the engine's on. So there are 4 tests that every technician should know how to do in an electrical system. That's number 1, and this is number 2.
Battery voltage state.
Now, here's the crucial importance of this test. If I put my voltmeter on and I got 14 volts when the engine's running, do I have to take the alternator out to take it down to Pep Boys or AutoZone to test it?
No.
No, I just did.
Yeah.
They're not going to tell me anything I can't figure out with a voltmeter.
Yep.
Will that inductive tool read the amps?
Yes, sir. That's its job. And see, it does AC volts, DC volts, ohms, and continuity test, and AC amps and DC amps.
Cool.
Used, it should cost you like 70, 80 bucks, but the amount of
113 on Amazon.
new though, right?
No, used.
Whoa.
I don't trust Amazon anymore because they take so long to ship. I mean, I do all my stuff on eBay now.
eBay, the cheapest one was $132.
Wow, really?
Plus some blood. It's worth it.
Is that new or used?
Was used.
Okay. Just wondering.
Really? Huh. Well, I don't know how much they are new. Well,
300 and something.
no way. Really?
Does Craftsman make one?
Probably.
That's the question, right?
They probably do.
Okay. Let me show you something about meters that I want you to be very clear on.
There's a really awesome one that has a detachable clamp.
I don't care about that. Let me show you this. Well, I mean, you know, awesome stuff costs money. That's why I'm not into it.
Right.
So,
Yeah.
voltmeter.
Go.
And then I'm going to go to images. Okay, let me show you
Oh,
something.
wow.
Oh.
What you want to do and what you don't want to do. What you don't want to do is get a meter that looks like this, where you have to set it to like 20 different settings. No, that's not what we want. What we want is something that's auto ranging. Then we can be happy in our work. Like that? No, it's still lame. All right, let me check. AUTOANNG. The hell? Auto ranging multimeter. There we go. Okay, look, this is what you want right there. Then you'll be happy. See, it says AC volts, DC volts, ohms and continuity, millivolts, milliamps, microamps. I'm not saying you want this exact one because you don't, but you don't want something that makes you have to choose between 80 different volt settings. You don't. You just want something where you can put it on volts and it's going to read volts, right?
Yeah.
Something like that. That's for phone guys. That's a Craftsman, isn't it? Yeah, see, it's just got 1 for volts. It doesn't have 98 different settings on it.
So just keep it simple then.
Look, there's a clamp amp one.
Yeah, see, it says auto ranging. That's what you want right there, auto ranging. You can get X-Tech stuff pretty cheap, and it's good, at least in my experience. I would not suggest getting this setup. No, I would not. I would get a separate amp clamp, but I mean, you can do it this way. It's just then you have to translate what the results are, and I'm not sure that's a good idea, particularly. But see, look at this. Come on. Look at this. See how simple it is? Well, even I can figure this one out. Now, this one just says volts, which means you're going to have to choose between DC and AC. But you're going to have to learn. You're going to have to learn to use these meters, right? If you want the power that the meter gives you, you're going to have to learn how to use it.
Yeah.
So do yourself a favor. Don't get any meters that aren't auto ranging. And I hate to say it, but there's some place that we always go that's really, really cheap, and all their stuff comes from Wuhan. Anyway, they have a little meter. Yeah, well, I wasn't going to say that, but they have a little cheap meter that really, really sucks. I don't know. I don't really like their good meters, but their cheap one is terrible. Stay away from it because it's just going to confuse you. They're not accurate. And, an instrument that's not accurate is bullshit, right?
Yeah.
Okay, so make sure you get something auto ranging. You can find it cheap enough. I mean, definitely under 30. So what do? We just slowly gather our tools about us. Incidentally, if you're not already on Electude, or if you didn't get an invite, you got to send me your email address because I don't have it. Let's see.
Did you put me on there? Okay, you Electude.
Yeah, I'll have to do it later though. Well, I'll tell you what, I'll do it during break. Yeah, remind me.
Matter of fact, I want to put it on a different email address. Hold on. The one to my computer.
Yeah, let me know. So this is the only people from this class that are already on this. So Jimmy Rodriguez, you need to get on it.
Get on.
Jimmy, I don't see your email address.
Give me that other email address for the computer.
What? The one that says
sorry.
3? What?
Sorry.
All right.
Hold on, I gotta find
Let me get out of here and go back to where
I need the.
Jimmy, you need to get on this. Let's go.
Let's
go back to, man, I've confused myself now. There you go. All right, so yeah, this is one of those things that really makes the difference, man. Because if you have to hunt down parasitic drain problems, this is the thing right here. I mean, if you see, because Chuck, what you do is you put this on. If you got a parasitic drain problem, which is defined as battery draw when the loads should all be off. There you go. Okay. What you do is you just put this on either the positive or negative terminal, it doesn't matter, and then start pulling fuses. And when you pull a fuse and the current goes down to 0, you've found where the problem is, right?
That's a good.
That much I know. Yeah. Okay. Incidentally, Chuck, are you on DIAG.net, Diagnostic Network? Are you there? Oh, you should be. It's wonderful. It's really insanely wonderful. Scott Brown is just going wild.
Oh, yeah. I put him on my favorites on my YouTube. Yeah.
Yeah, huh? So the stuff he's doing is just miles ahead of anything my experience or training ever showed me. But, man, it's just stunning. And, he went to Montclair High School. It's just, so that didn't stop him. Okay, so that's the 2 tests we have right there. You want me to show you number 3?
Yes, please.
Okay.
Okay, I'll show you number 3. This is called the battery available voltage test. And guess what? It's the same setup. The first 3 tests all use the same setup. You got your battery right there. Big old plus, big old minus. And we've got our meter right here. I would never use a meter like that, but it's just shorthand. BDC. Come on in here like this. That's my lead there. That's my lead there. Okay. So here's what you do on the battery available voltage test. The battery available voltage test is going to test what's really important to us because remember, really the only reason we have a battery in a car is to run the electric starter. I ever tell you the story of the electric starter? Cars didn't even have electric starters until the vice president of Cadillac, I think. His son was cranking the engine to get it started, and it broke his arm, and the infection ended up killing him because these were the days before penicillin, right? So it got infected, and he ended up dying. So that's how we got electric.
It backfired on him.
Yeah, that's how we got electric starters.
Hmm.
That's also why I got rid of my Harley. Man.
Really?
Anyway, the point I was trying to make was that, let me ask you a question. If I let air out of a balloon, am I going to lose volume or pressure?
Both.
Both.
Good, good. And if I let electrons out of a battery, am I going to lose pressure?
Yes.
Yep.
Yeah.
Let's say, for instance, like happened on the Suburban. We were working underneath the dash for like 6 hours with the door open. What do you think we found out when we went to test the vehicle?
Drain the battery.
Yeah, battery's dead. Sure. Okay, so battery available voltage test goes like this. I'm going to crank engine for 15 seconds. Now, my question to you is, how are you going to crank the engine for 15 seconds? Isn't it going to start?
Yeah.
Well, it would, but we have to
Disable the ignition or disable the fuel system.
We have to disable the fuel or ignition system. Now, how do you do that?
It's actually best if you disable both.
That's true. Yeah, that's true. But let's talk about that for a little while. If I disable the fuel, if I disable the ignition system and not the fuel system, all the injectors, while I'm cranking for 15 seconds, all the injectors are going to be shooting fuel, right?
Yeah.
Mm-hmm.
And all that raw fuel is going to go into the cylinder, and it's going to come out of the cylinder, and it's going to go straight for the what?
Catalytic.
Catalytic converter. Yep. And the catalytic converter is not made to process raw fuel, so that's going to jack up your catalytic converter pretty hard. Now, hopefully, we're not going to be doing this for 3 hours, right?
Right.
But
that's why you only do it for 15 seconds.
Yeah. Well, yeah, and you don't do it over and over.
Right.
Because we're talking about available voltage. How much voltage is available to start this car? And the reason they say this is because if you don't have a certain voltage, your spark's going to be so weak that you're not going to be able to start the car anyway. This is all about starting the car. Now, here in Southern California, we don't care about this because we never have problems with it. But when it's snowing and you got 6 feet of snow, this is a big issue.
Oh, yeah.
So here's what we do. We disable the fuel or ignition system. Which one should we do? I don't know. It depends on the car. You know, if the car's got a carburetor, you can't disable the fuel system. Really? I mean, you could put one of those plier things on the fuel line, I guess.
Yeah, you could. Put a plier on the fuel line or pull the fuel pump that goes in tank fuse.
Remember, it's a carbureted car. It's going to have a mechanical fuel pump.
It still has an electrical one in the tank, though.
Not the old cars I'm thinking of.
My plug had one.
Okay, so we'll say the easiest way to do this is to pull fuses.
Yep, pull the fuse.
And if you've got a fuel fuse, that's going to disable the fuel pump. Without the fuel pump, you got no fuel pressure. Without fuel pressure, you ain't going to be pushing fuel. Now, it's going to have some residual pressure as the pressure goes down, but it won't have pressure for long. Now, you can pull the ignition fuse. You can pull the fuel fuse. You can pull the computer fuse if you have to, but that's not really what you want to do. Okay, so we're going to crank the engine for 15 seconds. And we are going to measure the voltage at the 15th second. So while it's still cranking, we're testing the voltage, right? And let me ask you, what's happening to that voltage, battery voltage, as I'm cranking the engine? What's happening to it?
It's going down.
It's going down.
Oh,
yeah.
down. Okay.
Now,
Yeah.
ASE, when you take the test, the ASE spec which annoys me too, because this was the spec back in the 60s. The ASE spec says it must be minimum 9.6 volts. See, that's really going to pull the voltage down, especially if it's like a big engine or a small battery, or if it's cold, or if the engine's worn out. ASE spec, NIASE, that's the governing body that certifies technicians in automotive. They say minimum 9.6 volts, but I'll tell you, most of your modern cars, if they see less than 10 volts, they're going to shut off the injectors and the ignition anyway. So I don't see the use in testing something at 9.6 volts. Because remember, the whole point of this test was to get your car started. So according to me, which is correct, my spec is minimum 10.5 volts. And let me tell you something about this test. If you have a good battery, you're only going to drop down to about 11.5. In my experience, if you have a good battery, you might drop down to 11.5. If you're anywhere close to 10.5, you got to really reconsider that battery, according to me. You agree, Chuck?
I concur with that.
Yeah.
Me too.
Yep.
I'll second that.
Yeah. I was having some screwy issues because they put a used battery in the Suburban. So I was having some issues with it cranking slow. I just went down and supported my small businessman and got a battery with 1,000 cold cranking amps. And now it works great. So, I mean, because it's four-wheel drive, right? I don't want to get caught in the freaking desert with a car that won't start.
No.
No.
Yeah, it'd be horrifying, you know? So.
Hey, Rocliffe,
What?
let's come over and check and see if that's the option. It might be a better way to go.
You're cutting out, Boo. What'd you say?
I need to come over and check your Suburban to see if it's got dual battery option, like mine did.
No, there's no space for it. There's no space for it. I was thinking that too, but there's no space for it. Mute, folks. Somebody needs to mute.
Yeah, I think so. There we go.
There we go. Okay. All right. So, do my spec. If your battery's good, you're going to get down to 11.5. Now, my question is, what has to be true about the battery before we do this test?
Has to be fully charged.
Has to be fully charged. Good. Okay. Good. That's very important. Now, here's something you need to understand about charged batteries and checking battery charge by testing voltage. You got this?
Mm-hmm.
Yeah.
Test 3.
That's test 3. Sorry. Yeah, you're right. That's test 3. Okay. Here's what you need to know about testing voltage for state of charge. There's this thing called surface charge. And surface charge means here you've got this plate, but this plate is three-dimensional, right? Right?
Mm-hmm.
Yeah.
That is a battery plate. Speaking of which, battery plate, it's made of plastic and it's got a whole bunch of lead mashed into it, right? Now, let me ask you a question. If I take a donut and I dip it really quick in some coffee, am I going to get coffee through the whole donut?
No.
No, not the whole thing.
Right. See? And the same thing is true with surface charge. I can charge up a battery such that it's only charged on the outside of the plate and not all the way through. That's called surface charge.
Called what?
Yeah, and what it does is it fools you.
Surface charge.
Oh,
Surface
okay.
charge. Yeah, sorry.
It's okay.
Yeah, okay. So what it does is it fools you because you think, oh, well, this battery's at 12.6. But what you have to watch out for is when you put these leads on your battery, if it just has surface charge, what you're going to notice is it's going to go 12.6, 12.5, 12.4, 12.3. Because Because what's going to happen is the electrons are going to start soaking into the middle, and it's going to lower the voltage on the outside. Surface charge, you got to check. You got to watch out for this.
That's why when you go to do your load test after you've ran the car, you want to turn all your headlights on for 10 seconds.
Well, yeah, just a minute on that. Surface charge, you got to be very, very careful because it's going to make you think you've charged the battery completely when it's just charged on the outside. Yeah?
Yeah, makes sense.
So what we're looking for is, look for a stable voltage. Because what you're going to notice, if I was to go out right now and charge a battery with a battery charger, then disconnect the battery charger, what I would notice is the voltage would go 13.2, 13.1, 13.0, and that tells you that you've got surface charge.
Right.
So we got to look for a stable voltage. That's
How long do you have to look at it to make sure it's stable? I mean, just as long as it's not moving down?
15 seconds. Yeah,
Okay.
15 seconds, fine with me.
Okay.
Thank you. And Rudy's correct. The classic test for surface charge is, how would we say it? Enable all loads?
Enable a large load.
Yeah. Okay, you're right. Enable all large loads. So I'll put
with the car off, right?
Yeah, with the engine off.
Okay.
Yeah, because otherwise,
okay.
It's the charging system, right?
Yeah, right.
So
right.
what I would do is I'm going to turn on all the large loads, which would be the headlights and the fan motor. And what that's going to do is it's going to put a load on the battery. Now, if the battery is completely full, like a tire, for instance, on a tire, if I was to push the little valve stem, is the tire going to go flat?
Nope.
Mm-hmm.
No. Pressure will go down a little, but the tire won't go flat because it's got so much pressure. The same thing's true with your battery, right? If you turn on all these large loads, the voltage is going to come down, but it shouldn't drop like 3 volts or 4 volts. That just tells you got a surface charge problem and you need to keep charging the battery, yeah? Hey, how do you know if you're overcharging the battery?
Gets hot.
Yep, gets hot, right? How do you know if
It's hot, smells, you see the water bubbling out of it.
Yeah, put your hand on the side of the battery. Make sure it's not getting too hot, right?
Yeah.
Okay, so surface charge you gotta watch out for, but there's a simple test to get by it. So you want to see test number 4?
Yes, please.
Oh, you're so nice. Just like that. Just like this. We got plus right there. We got minus right there. This is going to require a ammeter. So this right here is going to come up to ground. This right here is going to go wherever it goes. I don't know.
Starter motor.
Yeah. And then I'm going to come in here. Uh-oh. I screwed that up. That's what I'm going to do right there. I'm going to come in here like this with my beautiful inductive ammeter. Something like that. And I'm going to put it on amps DC. Because this is a current test. And it's testing how much current the starter is drawing. Test number 4 is called the starter draw test. And the specs go like this. Max. That's 200 amps for a 6-cylinder.
Wow.
225 for an 8-cylinder. 250 for a 10-cylinder. And I guess that would be 175 for a 4-cylinder. Maximum allowable starter draw is this.
I didn't even know they had 10-cylinder cars.
Oh,
They
yeah.
have 12.
Vipers and big vans and trucks and stuff like that. Sure.
Okay.
Now, why does the maximum allowable current drop?
Ferraris, Audis.
I missed that question. I'm sorry.
Why does the maximum allowable current drop go up as the number of cylinders increases?
To meet the demand.
Yeah, because
Because the alternator is bigger.
It's doing more work, right?
Right.
Yeah. Okay, good. So those are the 4 tests every technician should know. The first 3 are, well, the first 2 are really simple. The third one's pretty simple. The fourth one requires an ammeter. Basically what we're doing here, Chuck, is we are coming close to mimicking the battery load test. This is the practical battery load test, right? Because we're seeing how much current the starter.
Let me ask you a question. Let's say you had a suspect starter. What would be the current draw?
Depends on why it's suspect. If it's got bad bearings and stuff like that, if it's jacked up inside, the current draw would be super high. Or if you had coolant in a cylinder or something like that, or if your bearings were shot, the current would be super high. Now, how could you mimic that? I guess you could get a big old breaker bar and see if you could turn the engine. Because one of the things, when you get a whole lot of current draw like that, you're forced to question, is it caused by the motor or is it bad starter? You know, something's causing the current draw. One time I was teaching and the guy pulled out the spark plug and he cranked the engine and it just shot freaking green fluid about 12 feet. Sorry, dude. And then he was like hitting me up like, Rocliffe, why don't you help me? I'm like, dude, what can I do? All right, you got this?
Mm-hmm.
Yep.
All right. Questions, comments, thoughts on that? Where are we
Need a
going?
new engine.
Let's say what?
Need a new engine.
Yeah, exactly, right? Okay, so, sorry, dude.
Blow cooling 12 feet. You need a new engine.
Right. No, but you know how people are with cars. You know, sadly.
They're babies.
Yeah. Let me ask you a question. Go back to this simple circuit just because it's fun.
Yeah. God. Rats.
That's drawing 2 amps. PEIR. Hello, young pup. What?
Oh, dead the puppy.
Hello.
What's the voltage? 12?
Yep.
Oh, shoot.
Good time, Mr. Hound Dog. Yep. So we know we got 12 volts and we got 2 amps.
Okay.
Easy money. Money's just laying there. Who's ready to take it?
I got
All
it.
right, done.
Okay. 2 times 12 is what?
4.
24.
6.
2 times 12 is 6?
24.
24 watts. Yep. Now, 12 divided by 2 is what?
6.
6.
6.
Now, look, Daryl. We multiply up, right? 6 times 2 is 12. 2 times 12 is 24.
I'm kidding.
We divide down. 24 divided by 12 is 2. 12 divided by 2 is 6, right?
Yeah.
So multiply up, divide down. Easy money.
I can't lie. I'm still kind of lost because I'm still trying to figure out the definition of the PEIR. P-E-I-R.
Right. Yeah. Yeah. Well, that's power. P for power.
Measured in watts.
Measured in watts.
Power measured in watts.
So, for example, like a 600-watt amplifier for your car, it's 600 watts or power.
Okay.
And you can take that by the voltage, say, I think they run them at like 14 volts. And then you can figure out what your amp draw is and how much resistance is in that amp.
Okay.
Yeah, watch the video from last week. It'll help you a great deal.
Yeah, I'm gonna catch up. I'm just trying to get back in.
Yep. Yeah, I'm glad to hear it, bud. Okay, so
You got my phone number, right? Does everybody have my phone number?
We'll get it later.
I'll just put it on the
I got
chat.
I do.
Yeah, that's probably a smart move, Rudy. That way it won't show up on the video. Okay, so my question is, I've got 2 amps at the bulb. Where did it come from?
Came from the battery, the power source.
Power source, yeah.
Power source, right? Yeah, okay. So how many amps came out of the battery?
12.
No.
Right?
No, that's volts. How many amps came out?
2 amps.
2 amps.
Yeah, 2.
Okay, and how many amps ran down this wire?
2.
2.
How many amps went down the ground?
2.
Good, because this is what we call a series circuit.
Right.
And in a series circuit, current is the same everywhere.
Yeah.
And Chuck, that's really diagnostically powerful, because that means I can check the current at the battery and know how much energy the third tail light is using. That's really, really powerful, you know? I can check the current at the battery and see how much current the fuel pump is using if I go around the right wire. Okay, so here's the important thing. I used to say it like Sancho's, right? If 2 Sanchos jumped in the window, how many Sanchos came to the street?
2.
2.
I missed it.
And how many Sanchos ran down the alley?
2.
2.
There you go.
Gosh.
Yeah, see, now everybody understands.
No, I haven't heard that term in a decade. I'm laughing about that. I grew up in East LA, so I'm just saying.
That's probably good, then. That's probably good. All right. So now my question is, I have my inductive ammeter, right? And it's very difficult to get access to any part of this circuit except right here. If I test the current right here, does that tell me the current flow everywhere in the circuit?
Yeah.
Yes.
It does. It does. Powerful, powerful tool right here, man. Plus the understanding that in a simple series circuit like this, maybe I should put simple. Ah! Doggone it. Oh, okay. In a simple series circuit, the current is the same everywhere. What do you want? Okay. Well, let's see. Let me just review for a minute. What's that?
The switch?
That's a switch. Good. Now, right there, the switch is open. What type of resistance does it have? High or low?
High.
Incredibly high. In fact, the resistance is so high. Remember, all resistance is resistance to flow. Yes?
Yes.
All resistance is resistance to flow, which means if the resistance is super high, what happens to the current flow?
Less flow.
Yeah. In fact, how much flow are we going to get here?
None.
None. What's going to be happening with the bulb?
No light.
No light.
Okay. But, Jim, this bulb has 4 ohms of resistance. Now how much current flows?
None. The switch is still open.
Right. Yeah.
Good, good, good. Because this right here, we got to think of things in electrical terms. This is super high resistance. switch is open. Now, if the switch is closed, what happens to the resistance?
It goes down.
It goes down to nothing. Yeah, basically, well, it should go down technically to just the resistance of a piece of wire that long. Should be, basically, in terms of this meter, it would be 0. Yeah, it'd be 0. And then we would start calculating using the ohms of resistance, right?
Right.
Okay, so let me ask you a question. Now the switch is closed. Oh, okay, well, let me ask you a question. Is there current flow anywhere in this circuit right now?
Not with it open.
How do you know that?
I don't know. I read.
Michelle, this is tough, man. I don't think I've seen many students that ever picked it up that fast. Yeah, there's no current flow anywhere because remember, in order to have current flow, we have to have a complete circuit. For current to flow, there must be a complete
Circuit.
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 Yep.
Circuit.
Yeah, someone's mic is being against us.
Yeah.
Quack. Quack, quack.
Quack, quack.
Oh, God help us.
I thought it was mine.
Rudy, your microphone is terrible.
I think we're all echoing.
Not mine.
Am I echoing?
Yeah.
We all are.
Okay, somebody needs to turn their mic off.
Well, it's not me because I was just muted, so it wasn't me.
I'm doing it, so.
It's not me.
All right, what y'all hear?
Okay, so here's the thing. If you put yourself on mute, if you want to unmute yourself and say something, all you have to do is hit the space bar on your keyboard.
Oh, damn.
How do you do it on a phone, though?
I don't know what I did.
A little microphone.
Oh,
Okay, yeah.
Oh,
Okay.
keyboard.
All right.
I pressed the wrong button.
You got this?
Yep.
Yes.
Yep, got it.
A lot of pages. Okay, so there we go. Now remember, the word circuit comes from the same word as
Circus.
circuit. Well, it probably does because the circuit has rings in it, right?
Mhm.
Okay, so the circuit comes from the same word as circus. I'm Scott. This is your fault. Circle. Can you see that there is a complete circuit going all the way around?
Yes.
Now, let me just blow your mind a little and go like that. Doesn't have a grounded conductor. What's the difference between those two circuits?
One has a resistor.
That's not a resistor.
Well,
No? Oh, wow.
battery and direct current and AC current.
Good. That's a resistor.
Okay.
This is alternating current.
Uh-huh.
Arnold, man. Known as AC. This is direct current. How do you know this is direct current?
Because it's only going one way?
Because it's got a battery.
Because it's got a battery. Good.
Okay.
DC. Okay, so if I'm testing volts, it's going to be this one, right?
Yeah.
The solid line with the dotted lines underneath it.
Mm-hmm.
Well,
That's
this
where it
one
is,
is going to be the volts with the wavy
Little squiggly.
line. Yep, with a little squiggly. Yep.
No, Kitty, don't sit on the computer.
So what does alternating current mean? It just means the current flows this way and then it flows this way. It flows this way, then it flows this way. It flows this way, then it flows this way. It's created by rotating magnets.
Okay.
But that doesn't matter. The important thing is, as long as I've got current flowing through this bulb, it's going to do what?
Powers the bulb.
It's going to light up, right?
Yeah.
The bulb doesn't care which way the Sanchos are running. It just wants Sanchos. Thought I didn't know, but I did.
Thought I know, but I did.
So, alternating current. It's the same thing. Okay, so I got 120 volts here. Just like this is the circuit. This is like when you plug in a lamp at home. Okay, so this draws, I don't know, 12 amps. So, just bang it out, right? PEIR.
120 and 12, okay.
20 volts. I got 12 amps. How much resistance?
10.
Good.
10.
How many watts?
Oh God.
1,400.
1,400.
Yeah.
Yep.
Yeah. Okay.
That's an insanely bright lamp because this is pulling
Yeah.
as many amps as a skill saw does.
Wow.
So that's good. You could probably cook your lunch underneath this lamp, but whatever.
Hey, Dave, we use heaters on the machine that are 1,700 watts.
Wow.
Yeah. See.
Yeah.
Exactly.
Yeah. But they're 200. But they're 240 volts.
Wow.
Yeah.
That's a heater for you right there. Well, I don't know about that. Yeah, I wish I understood how electricity went. Then I could understand what Jim was saying. Because he says that there's 240 volts and 17 amps. So let's say PE.
No. 1,700 watts.
Oh, sorry. You're right.
Yeah.
1,700 watts. I don't have a calculator with you.
Yeah, I don't have a calculator either.
It's a lot.
It pulls 7.08 amps.
7.08.
And how many ohms?
How many ohms?
We're gonna multiply that times that.
Make sure,
So
Rudy.
1,400. 14? No.
33.90.
That's it. My Spanish is going to hell now. I don't use it anymore. But yeah, this shirt used to be tight. Wasting away. Well, it is 7:30, folks. So
Okay.
You want to give it 15 minutes?
Sure.
Cool, man. Appreciate
Later.
it. See you in 15.
All right. Bye.